So in the given figure, a right triangle ABC circumscribes a circle of radius r. If the measure of side AB is 8 cm and that of BC is 6 cm, then we have to find the radius of the circle. So here a right triangle circumscribing a circle is given where AB is 8 and BC is 6 cm, and our aim is to find the radius of this in circle. So let us start our solution. First, let us focus on triangle ABC. Here, using Pythagorean theorem, we can write AC square, that means square of hypotenuse, is equal to AB square plus BC square. We have the values, so let us substitute them. AB as 8 and BC as 6. On simplifying, we will get AC is equal to 10 centimeter. So let us label it on the diagram. Now moving ahead, we see that angle APO, angle CQO and angle ARO, they are 90 degree. Why? Because we have this theorem that the tangent at any point of a circle is perpendicular to the radius through the point of contact. Moving ahead, we can write area of triangle ABC is equal to area of triangle ABO plus area of triangle BCO plus area of triangle ACO. So area of triangle ABC being a right triangle can be written as half times BC times its altitude AB. Now let us focus on triangle ABO. In this triangle, we can take base as AB and altitude as OP. So its area will be half times AB times OP. Now let us focus on triangle BCO. Its area will be half times BC times OQ. And likewise, for triangle ACO, the area will be half times AC times OR. Now let us substitute the values. So this will be half, BC will be 6 and AB will be 8, equal to half times 8 times OP, OQ and OR are the radius. Hence, in place of OP, OQ and OR, we will substitute small r. Now let us simplify. So we will cancel 2 in all the terms, and finally we will get 24 equals 4r plus 3r plus 5r. On further simplifying, we will get the radius as 2 centimeter. So the radius of the circle will be 2 centimeter. So if you want to get more such videos, do subscribe to my channel. See you in the next video.